Okay, so let's take a look at this type of projectile motion, which is a little different because the object, the projectile, is not launched horizontally. First of all, why is this projectile motion? What does it mean to be projectile motion? Projectile motion is anything that is launched or thrown through the air, which a football is. As soon as it leaves your foot, it is flying through the air on its own. That makes it a projectile. Why is this two-dimensional motion? As opposed to one-dimensional motion, a car speeding up and slowing down, a straight free fall problem where something is dropped off a cliff. This is two-dimensional motion because it is moving in X and Y at the same time. Which means when you do these problems, you have to solve for X and Y separately because they're two different dimensions of motion. So we got to think about X differently than we have to think about Y. So let's look at these concept problems. Note the changing shape of the ball's motion. What causes the motion to change? Why does it take this path? Well, that's because gravity works. You throw something up in the air and gravity's going to pull it right back down again. Well, after it leaves the kicker's foot, what is the acceleration of the ball in the y direction? Well, what's causing its motion to change is gravity. And we know an acceleration due to gravity is negative 9.81 meters per second squared. Now, after it leaves the kicker's foot, what is the acceleration of the ball in the x direction? And you got to say to yourself, does gravity work this way? And the answer, of course, is no, it doesn't. Gravity only works up and down, only works in the y. So in the x, there is zero or no acceleration in the x direction. What is the up and down, the y dimension, velocity of the ball at its highest point? So think about y. The ball's going up, and then it gets to some point where it starts coming back down. Now, that doesn't happen with X. With X, it's only going forward. But for Y, it changes its direction. It goes to a highest point and then starts to come back down. If you are going up and then you stop and change and come back down, and you have to stop going up before you can start coming down, that 1 millisecond, that one exact point in time where you change from going up to coming back down, you have to stop, which means your velocity at your highest point of a projectile is always zero. Your y velocity at the highest point is always zero. Does that mean the ball is not moving? That's not what I said. It just means in the y dimension, it stops for a second before it comes back down. Now it's still moving in the x dimension because it keeps moving this way in the x dimension the whole time. So let's think about this velocity in the movement of the ball. If we consider going this way positive, like we usually think of, and we think about this way as positive and down as being negative, let's consider the velocity at point number one, right the moment it leaves the kicker's foot. Is the y velocity positive or negative? It's positive because the kicker kicks the ball going in the positive direction. The x velocity is also positive because it's going in that dimension. Now at 2, the ball is still going up, so the y velocity is positive. X dimension is still positive because it's still going in that positive direction and it's still going in the positive y. Now right there at 3, y velocity is 0 because it is stopped for a second. The x velocity is still positive because even though it's stopped moving up, it is still moving forward at that moment. Here at 4, now the ball is starting to move down. That would be a negative y velocity, but the x velocity is still positive because it's going that direction. And finally, at 5, ball is going down, which is the negative y direction, but it's still going forward, which would be the positive x. Once again, these are all concept questions. Note the angle. So it's at 58 degrees, and the ball has a velocity. And that velocity is 25 meters per second. Some of that 25 meters per second is x, and some of it is y. The question I'm asking you is it more x or more y if the angle is 58? Well, you know that 45 would be halfway. It would be just as much forward as up. This angle is higher than that. So we have more y velocity and less x velocity because that angle is greater than 45. Now we're going to do some math. So we'll go forward. So what is the ball's starting velocity going forward? And then we'll answer this. So we know that it's going like this, and its starting velocity was 25. And we can split that 25 into its x and its y components, right? X and its y. Well, I can do this with trig. SOHCAHTOA, sine of this angle is the opposite over the hypotenuse. Well, the opposite side, that's the y side. I want the x sine. So the cosine of my angle 58 is the adjacent over the hypotenuse. And the adjacent is my x. It's my going forward part. Cosine is the adjacent over the hypotenuse, 25. So my adjacent side of my velocity triangle is going to be my x. That would give me a velocity of 13.2 meters per second. So when the ball is kicked, it is moving forward with a velocity of 13.2 meters per second. And the second part of that question is, what is its velocity at 5? You go over to 5, it's still moving forward, but what is its x velocity there? Well, think about this again. There is no acceleration in the x, so the x velocity stays constant the whole time. If it started off at 13.2 meters per second, it's going to finish at 13.2 meters per second. Now, what's the ball's starting velocity going up and down? Well, it's the same thing. We're going to have my triangle of, there's my 25 meters per second. That's my x side. That's my y side. To find the y side of my velocity, I got to use the sine function because sine of this angle is the opposite over the hypotenuse. So the sine of 58 is the opposite, the y, over the hypotenuse, 25. So my y velocity comes out to that, 21.2 meters per second, which is more than my x, which that's what we said up here. We predicted that we'd have more y velocity than we would have x, and our numbers bear that out. So now we want to know, how long will it take the ball to get to the highest point? I'm looking for a time. I want to know the time it gets to there where its y velocity is 0. This is a very important point in projectile motion problems because I know that y velocity there is 0, and it allows me to do some math a lot easier than otherwise. So let's go to our kinematic formulas. How long will it take? Let's find a formula that has to deal with time. Well, I can't use this one because this is that no acceleration one. That doesn't work in the y dimension. If my final y velocity is 0, I know my initial y velocity. I calculated that. It was that 21.2. I know the acceleration because it's that negative 9.81 because it's gravity. I would only have one unknown. So I can use this formula to solve for the time. My y velocity is the initial y velocity plus acceleration times time. Well, my velocity up there is 0. That's convenient. My initial y velocity was 21.2. My acceleration, negative 9.81 in time. So now I can solve for this, and I can actually get a value for my time. When you do the math, you get a time of 2.16 seconds. Oh, we'll make that 2.2. Now this next question, notice it says, how long will the ball be in flight total? I don't ask you to calculate it. If I know it takes 2.2 seconds to go to the highest point, I also know it's going to take 2.2 seconds to come back down. Because what's changing the motion here is gravity. And gravity is the same going up as it is coming down. So if it takes 2.2 seconds to go up, it's not like gravity changes all of a sudden and gets stronger and is going to pull it down quicker on this side. If it takes 2.2 seconds going up, it's going to take 2.2 seconds coming down, so long as it's going down to the same point that it started at. So how long will the ball be in flight total? I'm going to round this. I'm going to say 4.4 seconds. I'm going to call that 2.2 just to make it easy. Now, how high is the ball at its highest point? That's a distance question. Specifically, distance in the y. Can't use this for y because it's got no acceleration there. We know we have acceleration y. This one has no distance in it at all. Let's look at this. At the highest point, I want to know the distance in the y. Do I know the acceleration in y? Yes, it's gravity, 9.81. I know the time to the highest point now. Do I know how fast it started when it was kicked? Yes. And I know how long. I can use this formula. I don't even have to rearrange anything. It's going to solve for distance for me. So distance, and I'm going to actually say in the y there, dy is 1/2 at squared plus the initial time. So my 1/2, 9.81, my time is 2.2 seconds. Remember, I'm not talking about the whole time. I'm talking about the time or how high it is at its highest point. So I use that time it took to get to the highest point. And when I do the math, I get about 23.7 meters high. Now, how far will the ball travel forward? That's also a distance, but that is a distance in the x dimension. I like this formula because in the x dimension, where there is no acceleration, I can use it. The distance covered in x is the velocity in the x times however long it was in the air, all of which I know at this point. My distance in the x, velocity, time. My x velocity was 13.2. My time. Which time do I use? Do I use this half time or do I use the whole time? Well, I want to know how far will it travel forward? How far will it go over the whole trip? So I got to use the time for the whole trip. That's going to be that 4.4 number. I can multiply those two, 13.2 times 4.4, and I get a range or a distance forward of about 58 meters. Now, some extension questions, some thinking kind of things, help us get the concepts. Which velocity, the x or the y, determines how long the ball will be in the air? That's always y. Y always determines the time because the time is at what time does the ball hit the ground. Well, what pulls the ball to the ground is gravity. And gravity works in the y dimension, not the x. So you could kick this thing as fast as you wanted in the x direction, but it's still going to be the y stuff that's going to determine how long the ball is in the air. What would be different about the motion if the kicker had kicked the ball at an angle of 45 instead of 58? Okay, So when he kicked it at 58, he had more y velocity and less x velocity. If he kicks it at 45, you're going to have the same x velocity as y velocity, which means the x velocity is going to go up a little bit and the y velocity is going to come down a little bit. But what else might happen though? Will the ball stay in the air longer or shorter? The ball will actually be in the air a shorter period of time because you're not kicking it as fast in the y dimension. So it will not go as high in the y dimension, and that determines the time. Think about this. When a kicker kicks a ball, if he wants it to be in the air for the maximum amount of time, he would kick it straight up. But in terms of a football game, that doesn't do you any good because you want to kick the ball down the field. If you kick the ball really flat, like if you don't make enough of an angle, it's not going to be in the air long enough for your guys to get down there and cover the punt. So there's that maximum angle, that ideal angle, that 45-degree angle, which gives you the best combination of getting it up in the air, which increases your time, but also makes you have a little bit more forward speed, which will give you distance this way. If the kicker had used a heavier ball but still kicked it at that same velocity, what would change? Nothing. You could kick an iron football with the same speed that he kicked the regular football. As long as he could kick it the same speed, same initial velocity, everything about it would be the same. A baseball launched at that angle with that speed will come down in the same place as a football that is launched at that angle with that speed. Same thing with a shot put or a ping pong ball. The weight doesn't matter because gravity pulls on all things the same. And gravity determines the motion of projectiles. So it's going to treat all objects the same no matter whether they are heavy or light. So nothing changes with a heavier ball. Now, the angle makes a difference, the height from which you're kicking it, your initial speed, all of that makes a difference. But the weight of the ball makes no difference in terms of how long it takes for it to hit the ground. At this point, if you have any questions, feel free to email me. If you have any other problems, you want to come in and see me first thing in the morning before you take this test, or during flex, or even during lunch tomorrow, I'd be happy to answer any questions before we give you a second crack at that test.